Hi everyone, so today we're going to talk about one-sided and two-sided limits. We're going to jump right into a problem and look at the terminology and the concepts just using that problem. So let's look at number 2. So in number 2 they're saying graph f of x equals the absolute value of x divided by x, and then find each limit. So let's draw a rough sketch. Now first of all, this function is undefined when x is 0. Now, x divided by x will always give us the number 1. The only thing the absolute value sign can do is change if the answer is positive or negative. So if x is bigger than 0, we look at this function, we're going to have a positive number divided by a positive number, which will give us regular 1. If x is less than 0, we're going to have a positive divided by a negative, which will give us negative 1. So now let's use that to graph this. When x is 0, as we said, the function's undefined. When x is bigger than 0, the y value is 1. When x is smaller than 0, the y value is negative 1. So for part A, they're saying find the limit as x approaches 0 from the left of absolute value of x over x. So this means if you put in x numbers just a little bit smaller than 0, and what value is y going to get closer to as the x's get closer to 0. So as x gets closer to 0 from the left, the y's stay close to negative 1. Part B, they're saying as x gets closer to 0 from the right, what do the y's get closer to? So we look to the right of where x is 0. We see that as you plug in x numbers a little bigger than 0, the y's stay close to positive 1. In C, this reads the limit as x approaches 0 of absolute value of x over x. So this is saying in general, when x gets close to 0, what number does y stay close to? Since on the right, y stays close to 1, and on the left, y stays close to negative 1, there is no one value that y stays close to. So we say that our limit is dne. And just something I want to note is that when you're looking at the limit as x approaches 0, you don't care what happens when x is exactly 0. This is just asking what's happening when x is moving closer and closer to 0. So it doesn't matter that the function is undefined when x is 0. We're just looking for the patterns on both sides. Okay, we're going to try one more question. So let's jump to number 15. And in 15, we're asked to draw the graph of a piecewise function. So this tells us that when x is less than 2, we plug into y equals 3 minus x to get the y value. So we know that y equals 3 minus x is going to be a line. So just get 2 points and use those to plot the line. So if x is 0, y will be 3. So we're going to put a dot at 0, 3. Now, if x were 2, y would be 1. But we know that this rule doesn't work when x is exactly 2. Works when x is 1.9999, works right up until x is 2 exactly, but it stops working at 2. So we have an open hole at 2, 1. Okay, now we plug into x divided by 2 plus 1 if x is bigger than 2. So if x is exactly 2, this would give us a dot at 2, 2. We know that this doesn't work exactly at 2. It works for x is 2.001. So we're going to put an open hole at 2 and then just show that, right after there, we're still going to have a dot that will follow this pattern. All right, so now let's try an easy number for x, like 4. So if x is 4, y would be 3. So we have another dot at 4, 3. So now let's use this graph to answer the limit questions. As x approaches 2 from the right, the y's are getting closer to the number 2. We could see that from our graph, or we could see that by just plugging in to this rule that they gave us. As x approaches 2 from the left, we can look at our graph and see that the y's are getting closer to 1. Could have also seen that by plugging in 1 to this rule up here. So now for the two-sided limit, it does not exist because the limit from the left and right are not equal. All right, guys, so good luck with the rest of this sheet.